Hi everyone, yeah, I'm glad to be here and thanks a lot for coming to my talk. So today I will make an introduction to reactive programming in JavaScript. How many of you did some reactive programming in JavaScript in the past? Some hands. Okay, so just a couple. That's cool. So this should be interesting for you. So before we start, why I created this talk and why am I speaking about the reactive programming here today. So I have a story for you. So once upon a time I was sitting in my office as usual and working on a project, and that was a project about building some real-time dashboards for logs. So it was a problem in my team, so we didn't know how to what technology to use to create some real-time charts and something that will be fast and with a good UX and with good performance in the browser. So I was sitting alone and thinking, reading what should be really good to use, and then yeah, I had that reaction when I figured out that reactive programming is like the tool and methodology that we should use for building that real-time dashboard with multiple sources and with good performance. So we worked on a project. We completed that. It was great. The customer was satisfied, and then I wanted to go back to the community and to write something about reactive programming. So I picked this title, like, why am I switching from React to Cycle.js? Cycle.js is something, so it's UI library for building applications. I will talk more about it later. But it was like a clickbait title, but like the whole article was talking what is reactive programming and then why you should use it, what are the pros and cons, and so on. And this article got really popular, so we got translated to Russian or even Chinese. And yeah, that made me really happy because I knew that I did something well and that people liked what I wrote here. And then one day I came to one of those articles and checked the comments, and I saw some people that came there to fight. So to fight that, and they were telling that React is the best library ever, that reactive programming is bad, Cycle.js is bad, we shouldn't use that. Or there were people that just coming to read the comments and then just like make fun of that. But yeah, at the end, people really didn't see the point of this article. So this is why I'm here today. So I want to change the whole approach and then talk about reactive programming in a different way. Also, yeah, this was my face when I was reading the comments, and yeah, it made me really sad to see that people didn't see the whole point. So I'm Jovanovic. As you heard, I'm working and living in Belgrade in Serbia. I'm running my consultancy agency called IJ Consulting. I'm working also with Near4. Have been working with them on a lot of interesting JavaScript projects. I'm working remotely, so if you want to work too, I'm running this website, jsremotely.com, where you can find JavaScript remote jobs. And I'm writing on my blog, and also you can find me on Twitter. So let's go to reactive programming again. What is exactly reactive programming? So if you ever read something about reactive programming, probably found Anders Staudt. He's like one of the guys that's always writing about reactive programming online. His articles are really great. He also created a bunch of modules for working with reactive programming, and this is what he says about reactive programming, and I think this is the best. Reactive programming is programming with asynchronous data streams. So you know what's programming, we know what's asynchronous, but what exactly is a data stream here in this sentence? So what is a data stream? Data stream is just the endless sequence of digital signals or data packets. So you have just like sequence here, so a line where you have a lot of those digital signals or data packets. They can contain any kind of data. So this is exactly data stream, and reactive programming is just working with those data streams, putting them inside applications, and returning them back to the world. So just circling around using data streams. Specifically in JavaScript, reactive programming is just the abstraction of all async processes into a data stream. So whatever we have that's asynchronous in the application, we can use reactive programming on top of that, use that abstraction to work with the same API with those async processes. So how working with data streams looks like. Imagine that we have some sequence of data, like we have some 3 buffers, then we have 2 buffers, and then we have 1. This can be like user clicks. So user comes to a page, clicks 3 times, clicks 2 times, clicks once. And then we can create like a buffer data here from those buffers, so we can group them, and every click that happened like in 500 milliseconds, they will be together. So we have like 1 buffer of 3 clicks, 1 buffer of 2 clicks, and 1 buffer of 1 click. Next, we can take this data stream and then do some operation on top of it. So we can map through the stream, and then we can get the size of every buffer. So we can create numbers, and that's something that we can work with. So this buffer with 3 clicks will become 1 data packet. Number 3, number 2, and number 1. So we have 3, 2, 1 numbers. We can work with them. We can do some operations on top of them, like filtering. So we want to filter every packet that has the number inside more or equal than 2. So we have 3, 2, and 1 disappeared. So this is like the final data stream that we can work with. By using this technology, so by working and transforming data streams, create really powerful real-time applications. So why do we need this? We now saw what's reactive programming, also saw what's the data stream, how to modify it. So there are a couple things. First one is external service calls. So on web, we usually need to communicate with some API endpoints, with WebSockets, with something that's outside of our application, and it's usually asynchronous. So we need something good to work with those external service calls. Then reactive programming gives us better performance. Also highly testable because reactive programming is mainly functional programming, so you just create functions that will work with data streams and modify them, so it's really easy to test those pure functions. Again, we have abstraction over all async processes, so anything that's async in our application, we can use reactive programming on top of that to work with it. Then predictable code, so just by reading the code, you will immediately see what the code should do. And also extendable code, so with pure functions, you can just add 1 more function on top of it, or a couple more, and that's really easy to expand that and create bigger things. Reactive programming, we have those observables. So if you ever read about reactive programming, you saw observable, and observable is just official terminology for the stream. So whenever you see observable, it means data stream. And we also have observer. So observer is a function or something that subscribes to the observable and reacts to whatever item or sequence of items comes to the observable. So you have like a function that's listening to every change on the data stream, and it will react whenever something comes to that data stream. So in JavaScript, in reactive programming, we have, of course, a lot of modules. I put just a couple of them here. So we have RJS. This is part of the Reactive X community. So you have RX Java, RX Ruby, RX PHP, whatever. So there is also RJS. It has the same API as other modules for other languages, and this is the most popular, but it's also the biggest. So it's same thing like Moment.js. When you use it, you need to be careful not to import everything because this is really big and complex library. Then there is Moz.js. So Moz.js has the best performance. You can check their GitHub page. They have some benchmarking there. Also, there's Bacon.js. It's like mature, so it's there for a couple of years, and it's It's really easy to start with. And there's also the newest one, I think it's Xstream. So Anders Staltz, the guy who had this first definition of reactive programming and one of the first slides, he created the Xstream. So it's the smallest one, and then it has just I think 50 functions, so that's really enough to start with. So as every JS talk, we need to talk a bit about React, and also I wrote this in my article. So with React, I would like to talk a bit of React cons. So why we wanted to use reactive programming and something else in the project I talked about at the start. So because React has some problems. First thing is data flow. So when they were building React, data flow wasn't really in their mind. So they want to create some small and fast library that will react on UI changes. And for using data flow, people created Redux or MobX or some new technologies on top of React to help them fix the problem. Then there are side effects. So if you want to use some API, you need to, and you're using Redux, you need to add middlewares and so on. So you need to add more libraries on top. There's nothing inside React that can help you handle those side effects. And also functional programming. So they're trying to change that now. React hooks, then we can use your functions to build our components. But when they built React, it wasn't building the functional programming in mind. So you can fix those things by using React and RJS. But yeah, you cannot just connect React with RJS. As I said, you need something in the middle, like Redux, to help you handle data flow, and then use RJS to help you with async processing and abstractions of everything that's coming from the third-party stuff. So that's why we wanted to use Cycle.js. So Cycle.js is the alternative. It's a functional and reactive JavaScript framework for predictable code. So you can find that on official website. And also Cycle.js was built by Anders Staltz, so the guy from the first slides. So this is exactly what we wanted in our project. So a functional and reactive framework that will help us have the good data flow, handling side effects using functional programming. So the things that were cons in React are here pros. So these are the pros of Cycle.js. So data flow. Cycle.js is coming with data flow in mind immediately, so it's really easy to set up the whole app and to have the data circling around the whole application. Then the side effects, so there are a lot of plugins immediately coming with Cycle.js that can help you handle everything that's living outside of your app. And also functional programming. Everything in Cycle.js is just a pure function, so starting from components to any other methods. So it's highly testable, and you can immediately jump on this. So what are the features of Cycle.js? First thing, yeah, just functional, just write pure functions. Nothing really, not many things to learn there because it's just pure function. Next one is reactive, so it's coming with reactive abilities. You can use Xstream, or you can use RJS, just embed them and it will just work. It's highly testable, so just pure functions, really easy to test. Then it's composable, so you have components as pure functions, and you can use one function, put it inside another, and then compose them and create bigger and more complex components. It has explicit data flow, so you don't need to think how everything works. Data just circling around, so that's really easy. And it's also kind of made for a large code bases, because one file can contain just one component and everything can be inside. So starting from styling to how it looks to the whole functionality. So you need to create complex folder structure. And this is how Cycle.js looks like basically. So we have our main application running here. We have some side effects, and we have those sinks and sources circling around the whole app, and also be connected with the side effects. So here inside the the main function, so the main component. We have the pure data flow. See, everything that's coming in from the sources is a stream, so you can combine them, work with data, and then you return those streams back, so they are sinks. You return them back to the outside world, so to the DOM, HTTP, or anywhere else, and then DOM is being updated, the HTTP is, so you're setting new requests and so on. And then again, when something changes on DOM or HTTP or somewhere else, you again receive the source, and then your application reacts. So this is how it works, just circling around. And in CycleJS, this is like the main functionality. So you just have one method called run, and then you pass your main component, and you also pass the list of drivers. So app is just a pure function that should do something with the stream, and driver is just an object, so a list of drivers that, so basically plugins that you want to use for helping you with the outside world. So drivers, they're basically handling side effects, and we have HTTP, DOM, WebSocket, local storage, HTML5, notification, for example, anything that's outside there, anything that async can be here. People are creating their own drivers and publishing them, so if you want to use something else, there's probably a module already made for that. Those are official packages, so something that you get comes with CycleJS, you can install, or you don't need. I have a couple drivers here that are part of CycleJS, like DOM driver. So just collection of drivers that work with DOM. It's based on a SnapDOM, and it's like virtual DOM library. So it helps you to abstract anything that's on the DOM, so any side effect, any click or any input from the user will go inside your app as a stream, and then it will react on any stream that will come from the app back to the DOM. History API, so if you probably want to create routing, so there's history driver to help you with the history API. Same thing with the HTTP, so if you want to send some requests. There's isolate, so it's a function that will help you isolate your components so you can compose them later. And there are 3 run methods. So the first one I showed it just run. It's a run function that will help you, that works with Xstream. Then if you want to use most.js or RJS, there is most run or RJS run modules. And also, of course, CycleJS has its own design pattern for how you should create your own your functions. So how a component should look like. It's called model view intent. So it's like intent, model, and view. When you have your function, the source from DOM or HTTP comes to your function, then you have intent. So it's just used to combine and create streams. So like to parse streams that will just run into your function. Then you have models, so if you want to do some calculations to create a new stream from those that are coming from the source. And then you have view, so this is the place where you prepare the stream to be returned back to the DOM or HTTP. So this model view intent, it's really easy to explain using something like counter app. So you probably saw a lot of those examples where you have increment buttons, and then you have a counter, and then you click, it goes +1 or -1. So for creating this is the whole code that we need. So at the top here, we are importing Xstream, we are import run, we import cycle DOM, so we import some stuff from DOM, and then we have our main function, and at the bottom we just return, we just run the function and the DOM driver. So I will zoom into the main method. So here you see we have 3 parts, so intent, model, and view, and then we return here the DOM, so object with the DOM value and DOM key and value is the DOM stream. So intent part looks like this. So we have also here we have action. and there's a dollar sign at the end, so it's like convention that whenever you have some variable that's stream, you should put like a dollar sign at the end, and then when someone reads this, he knows that action should be a stream. And then we use here xstream to just like merge two streams. So the first stream is selection of the decrement button, listening for events, click, and then mapping. So mapping through this stream where every buffer will become -1, and same thing for the increment. So here we will have like two streams that will contain buffers whenever a user clicks, and we want to change those buffers to -1 or +1. So this action will just contain a stream with -1 or +1 depending on the user clicks. So then we have a stream with -1, +1, we can work with that. So we can use fold. Here, this is a model. So we are creating a count stream where we want to sum everything. So those minus and plus ones. We use fold, so it's like reduce function where we have starting from 0, and then we add a +1 or -1 on 0, and then create the count stream. And then in the view part, we are creating like a virtual DOM stream where we map through the count. So count will have numbers starting from 0 and then +1 or -1. So we want to map each of those numbers into a div. And then that div will contain button or two buttons and a paragraph with text counter and the count. So in this way, we started like from a stream of numbers, and then at the end, in the view, we are basically creating a virtual DOM. So the sources that are coming from DOM are numbers, so are like clicks, and then we map them to a div and return that back to the DOM. So that's like how we transform something that's coming from the outside world and returning it back to be rendered in the browser. So this looks like this. So you have like two buttons, and then by clicking there, you just decrease or increase the counter. How this works? So people usually ask me how this works with the CSS. You can just this virtual DOM library can work with CSS. You can just have like second argument in every component. You have an object with a style, so you can pass CSS styling. And also, if you don't want to use snap DOM, you can also use JSX. So it also works with it for like easier writing and reading the code. And like handling HTTP requests, this was like an example how we work with DOM, how we react on user input. Here's like an example how we can work with HTTP. We send like every second we send a request to the HTTP request, and then show like on the UI what's being returned. So this is like example. How can we use xstream to periodically, like on every second, how can we send a request? So we create some URL, we create some category. We create like every second we create a packet on the stream, and then change that to an object with the URL and category. So the HTTP driver will immediately know where to send the URL and what category to put. And we put category because inside HTTP driver, we receive a lot of requests, so anything that comes to our app. And then just we want to filter that by category, so we know what to show here. And then so we start first from the empty string, and then whenever some new request comes, we change our DOM and show response from the server. And then at the bottom, we need to return that request back. And yeah, we're almost done here. So just for the end, I want to show you how to work with components. So I said it's really easy to compose pure functions. You have like one method, and then you put it inside another, and you can put compose, so put one more above them, and create complex web apps. it works with the isolate method. So you just wrap your component inside isolate and then receive the something that's coming. So the streams that are coming from the component, and you can also create sources. So what streams you want to put inside the component. So what are the cons of the Cycle.js? It's not perfect, of course. First thing is community. So not many people are working with Cycle.js. If you have some problem, sometimes you need to solve it on yourself. You won't have a lot of people to ask. Then learning new paradigms. So reactive programming is hard. You will need to spend some time to learn it, to figure out how it works. And also, it's not for every app. So if you're building some simple application, something that's not really real time and don't have a lot of interaction, you don't need to use reactive programming. So, conclusion. Reactive programming is like the OR paradigm with a new usage. I think it's coming from the 90s, and now we are using it in a different way to help us solve some problems. It's not for everyone, as I said. It's not made for every application. And it's perfect for some real-time application that require high performance. So if you have like high interactivity in your app, this is perfect. Also gives you testable and predictable code, and it has all one interface for everything async in your app. So you can go to cyclejs.org to read more about that. You have getting started page, which is really easy. Also RX Marbles if you want to learn those methods that are coming with RxJS. And yeah, I will also post this, so I think we don't have time to explain, but yeah, some guy made an app using Cycle.js to view like real-time satellite data, which is a really cool article. I will post those slides online so you can check this article too. And that's all, yeah. Thank you very much. Yeah.
Yes, please.
Yeah, let's recreate. Okay, slide here.
Correct. Even you've got lots of really great questions, but sadly we are not able to answer them all. So just please select the Q&A. Yeah, pick the right room, switch to Q&A. Yeah, that's it. So the most liked question is, what does a larger scale app built with Cycles.js look like? Do you have a good example?
A larger scale app? Yeah, just the one that I worked on. So didn't really see that people use Cycle.js this much, so it's hard to find something a large scale. I have some code, so if you want, I can show you. But yeah, it's like a regular directory with a bunch of files with the whole code in components. So whatever, every component is like doing one thing with stream. So you split them up into files, put the CSS and everything inside that file and whole logic. And also how they look, so what should they return to the DOM. And then you just have a lot of those, so it's really not that complex. Again, yeah, Webpack and everything goes in, so shouldn't be that hard to work with it. It's like made for to be like simple.
Okay, I think you mentioned it, but people are still asking, if we don't write real-time application, would you still recommend reactive approach?
Oh yeah. Also, if you have like a lot of async stuff, so coming from the side. If you have like application that's communicating with the API a lot, or you have a lot of user interactivity, so user is typing, doing something all the time on the app. Reactive programming is really good because it will help you to abstract everything inside one API and then have the same code. So the same style of the code, same methodology for handling user stuff, for handling data flow, for handling APIs.
Okay. And our last question is, what do you think about current TC39 observable proposal?
Are you
familiar with it?
No, I didn't know there is like there is a proposal. Cool. Didn't check it, but yeah, it's.
Alright, so we can quickly answer the next question. What about hooks in React? You can have state management without Redux.
Yeah, I mean, you can have state management without Redux. Of course, you have also context API. But yeah, you will need to write a lot of code to set up everything. That's why I said like React is not really built with data flow in mind. And yeah, that's okay. They build it for something else, like for light UI library. You can have you can create like anything you want with hooks or context API, but this is just like an alternative library which has like data flow already set up there. So.
Alright, there are 12 questions left, so we
Okay.
don't have time for it. So if you want to ask this question to
Can I answer them here?
we don't really have time.
Okay.
Right? So maybe later on the after part or something.
Okay.
Is that alright?
Yeah.
Yeah, good. So please let's all thank Ivan for today.
Yeah, thanks a lot.